Okay, so we're going to be doing the temperature and specific heat for chemistry 1106. And for the first part, what we're going to do is the temperature part, part A. You're going to have rock salt. And here we have a beaker filled with tap water, and we have some ice. And so what we're going to do is we're going to use the thermometer to measure the temperature of the tap water initially. And then we're going to add some ice water, wait about 5 minutes, record the temperature again. And then we're going to add some rock salt into the mixture of the water and the ice water and measure the temperature again. Okay, so let's go ahead and do the initial measurement of the tap water. And here we have our thermometer. And so what we're going to do is I'm going to get it closer over here so that you all can see what we're doing. And we're going to measure the temperature. Whoops. Measure the temperature. And here we're at about 20. And so what I'm going to do now is I'm going to zoom in. And hopefully this works. So let's lay it down for a little bit so that I can zoom in. Oops. You can see it there. Temperature. Oh, now it's recording. All right, so we're gonna add the water. We're gonna add ice to the water here, and then we're gonna wait for 5 minutes and then record the temperature. Okay, so we gotta add about 2/3 full. Let's see, it's at about, let's see here. One, two, a little more. I think we should be fine there. Okay, so I'm adding the temperature now. I'm sorry, I'm adding the ice, and we'll record the temperature right now in 5 minutes. Okay, so now we have waited the 5 minutes, and we have our ice water mixture. And so in our ice water mixture, we're now looking at the temperature. Hopefully I can zoom it in for you. And let me see here. All right, zoom it in. And our temperature slightly above 0. So you can record your measurement. The next thing we're going to do is we're going to measure out 30 grams of the rock salt, about 20 to 30 grams, and then we're going to add it to our mixture, and then we're going to wait 5 minutes and take our temperature again. Okay, so now we are going to weigh out about 20 grams of the rock salt. And so we put a little weighing paper on top of the scale. And so that's where we're going to set our rock salt. And we're just going to zero it out. And so hopefully you can see here. So about 20 grams. Oops, dropped on. All right, so we're gonna put approximately 23.63 grams of the rock salt. And as you can see here, 23.63 of the rock salt. And we're gonna put it onto our mixture. Okay. Okay, now we're going to make our addition of our rock salt into our mixture of ice and water. And so we're going to see the effect of temperature that is given into our idea. Okay, so now we're going to go ahead and wait about 5 minutes and to see what happens to the temperature, if it stays the same or if it increases, decreases, or whatnot. Okay, so as you can see, after I waited about 10 minutes, you can see the temperature. It's a little bit below 0. Here, let me see. And there it is. Make your measurement and record it. There you go. Hopefully that helps. So the next thing that we're going to do is we're going to do the specific heat experiment. And in this experiment, we're going to determine the specific heat of a cylinder here that I have, a cylinder piece. It is aluminum. And so based upon what we're going to do, the first thing that they ask us to do is we are going to place it on the scale and determine the mass of the cylinder, which is 14.32. And then the next thing that we're going to do is we're going to get our calorimeter, which is a styrofoam cup, and then we're going to measure the calorimeter or the styrofoam cup. Let's put it right in the center. And then the mass of the styrofoam cup is going to be 1.41, I believe. And then here I have a graduated cylinder, and in this graduated cylinder I have, if you can see the measurement, it's, I put my hand behind it, maybe you can see it better. If you look at the meniscus, it is right at 50. Okay, and so what we're gonna do now is we got to make sure that the water does cover the amount, or when I put in the cylinder, make sure because the cylinder needs to be submerged. And so what I'm going to do is I'm going to add the water to the styrofoam cup, or your calorimeter. And as I add the amount of water, because volume is affected of liquids with temperature, we're going to mass the volume, we're going to mask the calorimeter and the water in there as well. Okay, so there is your measurement. And so now what we're going to do is we're going to cover our calorimeter over here with our cardboard box for just the second. We have our thermometer here. So now what we're gonna do is I'm gonna take this down real quick just so that I can put it down a little bit lower. All right, and we'll heat up there approximately. And then we're gonna put our water bath, get our matches, start up our gas. And then go ahead and start our fire. And so here, we don't want too much. We don't want a crazy fire, right? We want to kind of control it. And so hopefully you can see that now our setup, we're trying to heat up the water, and as we heat up the water and it brings it up to a boil, then we're gonna submerge our cylinder into there with a string around it, right? And so when I talk about putting a string around it, so we're just gonna make sure that we wrap the string around, and so that when it goes in, we are able to take it out. And so I might have to get a little longer string, okay? All right, so we have our water bath system, which we are going to submerge the cylinder into the bath. Okay, I have the string attached to it. And so as you can see, if we record the initial temperature of this bath, let me see if I can zoom it in here. Come on now. All right. As we zoom. The lens is fogging up. Let's see here. Hopefully you can record it. We're at about 97, 98 degrees. Okay. All right, so now we're gonna go ahead and submerge into our setup and slowly lay it down on the floor. Lay it down on the floor. Lay it down at the base of the beaker. And then we gotta make sure that the string doesn't catch on fire, right? So let's go ahead and bring it around here so that it keeps it away from the flame. All right, we're gonna wait about 10 minutes. We're gonna boil for 10 minutes the metal so it can heat up, and then we're gonna transfer onto our calorimeter and see the heat. It will transfer, the cylinder will transfer heat onto the water, and then we're gonna see that the temperature of the water is gonna rise. So we gotta take the temperature of the water initially, and then based on that, then we'll see the heat transfer from the cylinder to the water that's in our calorimeter. And we're gonna measure it and see the shooting up of the temperature, and then the temperature is gonna go back down because the temperature between the cylinder and the water is gonna achieve equilibrium. So we gotta make sure we get that max temperature. Okay. And so we'll come back in 10 minutes after heating to determine to do the transfer. After heating for just 5 minutes, I'm gonna check the temperature again, see if it has changed or anything of the sort. And Jesus, man, must be going blind here. And so what I'm gonna do is hopefully you can zoom it in and get a measurement, get a good enough measurement. And hopefully you can see there that it's about 97 degrees. All right, gonna heat for 5 more minutes and then we'll do our transfer. Okay, so now we're gonna take the temperature of our water inside the calorimeter. Okay, and hopefully you can see. Not, hopefully this doesn't tip over. And our temperature is right there. Hopefully you can see it. And that's the initial temperature of the water inside the styrofoam cup, which is our calorimeter. Approximately somewhere around 20, what is it? 23? All right. So our 10 minutes are up, sorry. I was just trying to see if I am recording. Hopefully I am. And so we're gonna do our transfer. I should have definitely got it closer. Let me see, let's go ahead and move this just a little bit. So it won't take that long. So what I've done is I've essentially placed the thermometer, as you can see, hopefully. You can see that it is under there. What I'm gonna do is I'm gonna transfer that over and place it in the water, close it up, and then we're gonna watch the temperature rise of this mixture, okay? The addition of the cylinder, okay? So I'm gonna have it open. I'm gonna transfer it. Come on, get in. And as I do the transfer, now we're gonna enclose it. And we gotta make sure that the thermometer, okay, is in. We're gonna swirl a little bit so that we can see the temperature rising. And hopefully we can see it. And it is going up. And we are currently at about, as I take it off, take the headset off here, I'm gonna zoom in, and we can see at about 20, is it 27, 28? I'll look at it closer right now. I'm trying to give you the best view here. Hopefully the glare doesn't hinder your measurement. And there you go. We'll wait a little longer, see if it does go up. And so we'll see here as well. And I believe that'll be it. I'll continue to monitor it. That way I don't have you here holding. And if it does go up, we'll revisit the temperature. Okay, so for the next experiment, we're gonna do the energy and nutrition part of it. So we're supposed to get a food sample. And here I have some chips, some cheese puffs. They're called cheese doodles puffed, okay? And so what I'm gonna do is I'm essentially gonna get one of these cheese puffs that just fell out of the bag, and then you're supposed to see the nutrition label. So I'm gonna try to see if you can see it here. So the nutritional facts, right? 150 calories, which is approximately 9 pieces of the chips. And then here it tells you the saturated fats. I'm trying to get it as flat as possible, but not helping here. I will win, even with one hand here. And so we got the bottom part of it here. And let's get the top portion of it now. And those are the nutritional facts for that. And so what we have this set up real quick so that I can explain it. In the setup, I have 2 iron rings here. I have the ring stand. And then essentially they had, the book calls for the wire gauze to actually place it on there. But I was afraid because we have to mass it at the end. Once we're done burning it, we have to mass it again. And so my biggest concern is that some of that soot is gonna fall through. And so we're gonna lose some of the mass to the ground or to the table. And so the other time that I've done this experiment, I have a little cork here, and I've wrapped it around in aluminum, and I have a paper clip here. And so what I'm gonna do is I'm gonna attach the piece of food here, and then we're gonna lower this even lower so that it's slightly underneath the aluminum can, the piece of food, and then we're gonna ignite it, okay? And then of course, before we do all that, we have to definitely add our 100 milliliters of water, which we have here measured out. And so we've measured out 100 milliliters of water. and we're gonna transfer the milliliters of water into our can. But before we do all that, of course, we have our thermometer up here, which is gonna record our temperature change, because that's what we're after. And so with all that said, this is pretty much the setup that we're gonna do. We're gonna burn the piece of food, and we're gonna detect the temperature change of what the energy is being released by burning of the food, okay? Okay, so the first thing that we're gonna do is we're gonna measure, you already know the type of food that it is. We're gonna measure our aluminum can. And so as we get our measurement of the aluminum can, it'll be that. And then the next thing that we're gonna do is we're gonna add the water into our aluminum can and get the mass again. So now we're gonna transfer our water into our aluminum can. Okay, once we transfer it, now what we're gonna do is we're gonna get the mass of it. Sorry, there it is. Just trying to see if it's recording. So we transferred the water, 100 milliliters, into the aluminum can, and now we've recorded the mass. Okay, so that's the mass of the can and the water. The next thing that we're gonna do is we're gonna take the mass of the food, and so we have our puff, or cheese puff. And so we get the mass, and the mass, wait, let's double check real quick. There it goes all the way to 0, and it does, so we're good. The mass of the cheese puff, 1.37. And then lastly, now we're gonna go back to our setup, and then we're gonna record the temperature of the water. I forgot one last thing that we need to weigh, my people. Okay, and we gotta weigh our cork. So write it down on the side of your document somewhere, that we're gonna take the mass of the cork and the aluminum paper clip. Okay, so there's the mass. All right, so now as you can see, we have our setup, and I'm gonna try to get under there. We're trying to put the cheese puff as close to the aluminum can as possible. And so here we have our cork attached with our paper clip, the cheese puff. We got the ring, that triangle that's made out of clay, so that it can hold up the can so that the can doesn't fall through. And then we have the 2 iron rings. We have the aluminum can with the water in it. We have our thermometer set up. So then the last thing that we have to do is now record the initial temperature of the water. We have to make sure that the water is touching. And like I said, maybe you might not be too much intrigued, but I'm gonna shine a light there. Maybe we can see. No, I can see. Just kidding. And so our thermometer is submerged. And so now the only thing that we gotta do is take the initial temperature of the water. And so, as hopefully you can see, let me get rid of the glare. Let me zoom it in. And so our initial temperature is gonna be somewhere. Ah, that blue thing is not gonna allow us to see it. Well, we're gonna see. And there it is. Okay. It's right around 24 degrees Celsius. Slightly underneath that 25. Okay. Okay, so now we're gonna strike our match. So I usually have a lighter for this so that it can actually get it. So we're gonna extend it that way we don't get burned. I'm using a test tube clamp. Okay, don't try this at home, right? There's the disclaimer. So I'm gonna go ahead and light it, and then I'm gonna light the piece of food so that we can start with our experiment, okay? And hopefully it's enough. All right, and there our food is on fire. And so we're just gonna go ahead and wait and record the temperature. And so let me take this off my head now. As we can see, we're gonna record the temperature as it's gonna heat up the water. And so far, so good. Let's look at the fun part, right? And our temperature is not rising yet from the water. Soon will, hopefully, right? And so there's our rise. And so let's go ahead and zoom in a little bit to our temperature. And our temperature currently is about 36. And so it is about 39 degrees Celsius at the moment. You can see it there. And our reaction is done. So the highest temperature that has been achieved is at about 39 degrees. So that is our final temperature. So the last thing that we're gonna do is we're gonna get our what do you call it? Our burned cheese puff. And we're gonna go ahead and measure it. And as we measure it, we gotta turn on the scale first here. And here we go. We're gonna measure everything, and it's gonna be 5.79 grams. Now remember, we had already measured the cork wrapped in aluminum with the paper clip, so just make sure to deduce subtract both of those values so that you can get the amount of cheese puff burned. All right.